Just went to the store and bought a heck of a lot of paper, so my stack is a lot higher than it used to be. Let's get back to work. Problem 8 is solve this inequality. So the inequality is 3x plus 6 divided by x minus 4. We want this to be strictly less than 0. Now, this is the sort of place where we can't just multiply, on both sides by x minus 4 to cancel that out and go from there. That doesn't work when we're dealing with inequalities. Instead, what we need to do is make a sign chart. So we want to think about when the numerator and the denominator are each equal to 0. The numerator is equal to 0 when x is equal to negative 2. The denominator is equal to 0 when x is equal to 4. And so let's make a chart here about what's going on when x is less than negative 2, when x is between negative 2 and 4, and when x is larger than 4. When x is bigger than 4, so for example, x is equal to 5 works over here, this expression is 3 times 5 plus 6 over 5 minus 4. This is something positive over something positive. The expression is positive for x larger than 4. Let's test something like x is equal to 0. It's between negative 2 and 4. This looks like 3 times 0 plus 6 divided by 0 minus 4. This is positive divided by negative. This is a negative number. And finally, when x is less than negative 2, then we have, just as a sample, x is negative 3. This will be like 3 times negative 3 plus 6 divided by negative 3 minus 4. 3 times negative 3 is negative 9 plus 6. This is negative. Negative over something negative gives us a positive answer here. And so the expression is positive if x is less than negative 2. It's positive if x is greater than 4. And it's negative between negative 2 and 4. So this is our answer, and we were asked to write our answer in interval notation. So the interval is negative 2 comma 4. We exclude the endpoints. When x is negative 2, the numerator is 0. So this expression is 0, and 0 is not less than 0. When x is 4, we're dividing by 0. We need to exclude the endpoints. Okay, problem number 9. Final domain of the function f of x is log of 80 minus x over square root of x minus 5. So log of 80 minus x divided by square root x minus 5. There's 3 things going on here. There's the natural log, there's square root, and there's something over square root x minus 5. So what are the 3 ways that we could hit trouble here? Something about we can only fit in certain numbers. We can only plug in certain numbers into the natural log. We can only plug in certain numbers into square root x. We have to make sure we're not dividing by 0. So let's take each one of those 3 in turn. So natural log of x, the domain of natural log of x must be strictly positive. So this tells us that 80 minus x must be strictly positive. This tells us that x is less than 80. Whereas the square root here, square root x, this tells us that x must be greater than or equal to 0. Finally, dividing by square root x minus 5, this tells us that square root x minus 5 is not allowed to equal 0, which is x is not allowed to equal 5. Sorry, square root x is not allowed to equal 5, which is x is not allowed to equal 25. So putting our answers together here, we see that x must be greater than or equal to 0, strictly less than 80, but x cannot equal 25. Writing this in interval notation, it's here is the answer. Let me write this out and explain it. So this is representing all numbers that are at least 0, but strictly less than 25, and everything from 25 to 80, not inclusive. It can be either this or this. We put a union symbol in between those to represent the fact that we're taking the union of these two intervals. Problem number 10 here, simplify this expression with logarithms. So logarithm of e to the 5th plus, and these are all natural logarithms, plus natural log of e to the 6th plus natural log of e to the 7th. Okay, so how do we combine logs together? We're going to use two rules here. The first rule says that an exponent inside a log comes down as a coefficient outside the log. And so this is going to be 6 natural log of e. That's a 5 there. And then this one is a 6 natural log of e plus 7 natural log of e. Now the next thing to realize is that natural log of e, these are all equal to 1. This natural log is base, logarithm base e of e, logarithm, so log base b of b is always equal to 1 here. So this is 5 times 1 plus 6 times 1 plus 7 times 1. And so our answer here is 18. That was part A of problem 10. Part B asks us to solve for x in 8e to the 7x is equal to 2. Dividing both sides by 8, we get e to the 7x is equal to 2 over 8 is 1/4. When we take the natural log of both sides here, natural log of e to the 7x, natural log of e to the 7x is just going to be 7x. And on the left here, this is going to be is equal to natural log of 1/4. So x is equal to 1/7 times natural log of 1/4. This is a perfectly reasonable final answer. There is one change that we could make here if we wanted to, which is we could rewrite this, the 1/4 here, as 4 to the negative first power. 1/4 is 4 to the minus 1. And then we can bring that minus 1 out in front and say this is negative 1/7 natural log of 4. These are equivalent answers here. One last problem here. Find the standard equation of a circle with, that should say center 42, 74, and radius 53. So that's going to be, so formula for the equation of a circle is just x minus the first component, the x component squared, plus y minus the y component of the center squared is equal to the radius squared. And there's no reason to simplify past this.